Welcome to follow up. Let's have a look at today's daily challenge problem. Problem 2870. Minimum number of operations to make array empty. Actually, the logic for this problem is rather straightforward. So we are going to quickly look at the requirements of the problem, and then we do the coding. So here we are given a zero-indexed array called nums consisting of positive integers. So there are two types of operations that we can apply on the array any number of times. So either we choose two elements with equal values and then delete them from the array, or we choose three elements with equal values and delete them from the array. So we want to find the minimum number of operations required to make the array empty. Otherwise, we return -1 if it's not possible. So here, actually, if we look at the two types of operations, so if for a element, its frequency is very large, so for sure we want to choose the second operation type as many times as possible, right, in order to minimize the total number of operations. So here, if you look at example 1, so here we have 2 appears 4 times, but for this, you only have one choice, that is use the first type operation twice, right? So here 3 appears 3 times, so we use the second type operation, right? So it's another operation, so in total is 3. So here we also have 2 4s, so this needs the first type of operations, so we get 4 for this example. The second example is very special. So here we can eliminate 2 because 2 appears 3 times, and also we can eliminate 3. 3 appears twice, right? But we cannot eliminate 1, so the output is -1. And for the constraints, so here the length of this list is at least 2, and it's bounded above by 10 to the power 5, and the nums is positive numbers greater than or equal to 1, and it can be very large, say up to 10 to the power 6. So this is the main requirement for this problem. So here the strategy, actually we just need to use division with remainder or integer division, right? So here the thing we want to make clear is that given the integer n positive, so we want to split it into linear sums of 3s and 2s, and with as many 3 as possible. So this is the problem requirement, right? So because 2 and 3 are relatively prime, so any positive number integer greater than 1 can be decomposed as above, right? Can be decomposed as above requirement. On the above constraint, right? So here, let's discuss the special case. That is, if for integer, just the count is n. So here you interpret this n as the frequency, right? So if n is 1, we cannot do the splits, so we just return -1 in this case. And if n equals 2, so we just need the first type operation, right? So we just give it 1 times 2. And in general, for n greater than 2, in other words, n is at least 3. So we can do a division with respect to 3, right? We look at how many 3s we can get. So if r equals 0, it means n is an integer multiple of 3. So this q is nothing but the number of operations we need. Otherwise, if r equals 1, right? So we need to combine of 3 and 1, because the 3 and 1 has sum 4. We need to use 2 operations of type 1. In other words, choose 2 elements to delete them. So in this case, we are going to get q minus 1 times 3, then 2 plus 2. So each 2 corresponds to 1 operation. So overall, we get q minus 1 plus 1 plus 1. That is q plus 1 operations. So if r equals 2, so we get n equals q times 3 plus 2. So in this case, we use q times of type 2 operations, and then use 1 time type 1 operation. So the total operations, number of operations is still q plus 1. So with the above analysis, I guess writing the code is rather straightforward. Let's look at the case. So the main thing here is that for each element, we get its frequency. So this is nothing but the counter, right? So we can do a count. So the collections counter, right? So we're going to do this, and then we can do the count. So let's initialize a result variable. If we are able to empty the nums list, so we are going to return the state of this result for counting the minimal number of operations. So we are actually only interested in the frequencies. So basically for v in count values, right? So you can interpret this v as the n here, right? So first case is if v equals 1, so we just return -1. So as long as we have some element with frequency 1, you cannot eliminate that. So you just directly return 1. So otherwise, so we are considering the case v is greater than or equal to 2. So for clarity, let's first consider the case v equals 2. So in this case, we just need one operation. So we increment the result by 1. So this 1 represents that we need the first step operation once. Otherwise, so v is greater than or equal to 3. So we can do integer division. So dev mode, so give a v and 3. So notice that because v now in this else block is greater than or equal to 3, q is always greater than 1, right? Greater than or equal to 1. So here, if r equals 0, it means that v equals 3 times q. So the result will be incremented by q. Otherwise, so we have either r, so let's see, else if r equals 1. So in this case, so we know that this v equals q minus 1 times 3. Then we have two 2's, right? So in this case, we need q plus 1 operations. So in this case, we have q plus 1. And otherwise, r equals 2, right? So we also need q plus 1. So let's just do this in 1. Else, we're going to increment the result by q plus 1, right? So if after this for loop, nothing returned, so we just need to return the state of this result variable. So this actually is a translation of this analysis. So let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So here, let me give some comments. So here we are using this collections counter object, which is a subclass of the dictionary. So if you are not aware of this object, or you want to do it from scratch, or you are a beginner, so we can do this. Let me copy this part. So I'm going to change this one to be version v1, and then here I can do the things like this. So I can initialize an empty dictionary. We just need a for loop for y in nums, then count y. So we are going to increment by 1. So we are going to use count get this y. So we want to get its frequency. If the y is not in the dictionary yet, we're going to give it a default value 0, right? So we get this. This count will play the same role as this one, as this line of code. Let's do a quick test. So this is another way of writing. So here we are using the get function. So basically, you want to get if y is inside the dictionary, or y is a key in the dictionary. So we are going to get the corresponding value. Otherwise, if y not in the key, so we are going to get a default value here 0, because we are considering frequency. So this is another way of writing this. So let me do another very simple change. So some people maybe write like this. So if, for example, if you see y, if y not in count, right? So we're going to set count y equals 1. Otherwise, we do count y incremented by 1, right? So this actually is the same thing, but this is the so here I got I changed the version v2 anyway. So let me copy this again. So I'm going to change this one, and I'll change back this one to be cont y equals cont get y0 plus 1. I'll call this one version v2, and this one is we're going to write, right? So here we write in this format. Let's do a test. Yeah, it's the same. Actually, these are very small details and very simple, but it's very good to make it critically clear so that you can make it easy for you to quickly digest all different coding formats. So with that said, I guess that's about it for this simple question. Thank you.